Day 25, page 655, problem number 59. Once again, with a little bit of practice, you will see this much more quickly than maybe the first time you look at this diagram. But essentially what you have here are four capacitors in parallel with each other. One way to kind of test that is to either mentally or physically, kind of with your pencil, walk around the diagram. You can do the same thing with resistors, but for example, if I'm going from the positive to the negative, which is the conventional current flow, there's not really current flowing here, but there's a pathway that I can take that gets me all the way around back to the battery, which passes through the 12 picofarad capacitor. And that's the only capacitor it goes through. There's other ways of looking at this, but if I erase that and then draw you another pathway, for example, I can draw a pathway through the 9 picofarad capacitor that gets me back around, closed path. That only goes through one capacitor. So far those two are in parallel with each other. Or if I do the third pathway, that's this way, any of these pathways requires me to pass through only one of the capacitors. So maybe if you look at this long enough, you'll see almost immediately that this is four capacitors in parallel. Same idea would hold true for the resistors. So if I draw the schematic for this, it would look as follows, simplified. It's four capacitors in parallel with a 12-volt battery. And I left off the units on purpose just for clarity here. It doesn't really matter which capacitor goes where. I have four independent pathways from the battery back to the battery. Bottom line is each of these capacitors will have a potential difference of 12 volts. But to combine them into one, that would be probably the fastest way to do this problem. When they're in parallel, you just add them up. So we have 9 plus 1 is 10, 20 is 30 picofarads. So we'll draw that diagram. So there we have the simplified diagram. Simply by combining in parallel, just add the values arithmetically. Couple approaches, but one approach is to figure out the charge. There's other maybe faster ways to do this, but just for practice sake, once again we have C equals Q over V, technically delta V, and C is 30 picofarads. Pico is 10 to the negative 12th, I believe. So we have 30 pico, remember to put the pico in your calculator, equals Q over 12. So Q is going to be 360 picocoulombs. That's the charge on that particular replacement capacitor. You can figure out the charge now on each one of the individual capacitors, and those would all add up to 360. They all have 12 volts potential difference, so you could calculate those individually. I'm not asking you to do that, but they might ask you to do that, like they might want to ask you to find the energy stored on a 9 picofarad capacitor here. But they're asking you to find the total energy provided, so I could do that individually for the four and add it up, or just figure out the energy stored in the 30 picofarad capacitor, which is a faster way to do this problem. I'm going way over to the left here. And there's a couple of equations, but the one I like to use is that the potential energy stored in a capacitor is 1/2 QV, delta V. So that's just 1/2 times 360 times 10 to the negative 12th times 12. I'll let you do the calculation there to get the final answer.